So my name's Richard. I'm on from Green Square Renewable Energy. So we've got 4 branches around the southeast, and we've established about 8 years ago, and we install into domestic properties all renewable technologies, from air source heat pumps, ground source heat pumps, biomass, solar thermal, solar PV, and MVHR, along with underfloor rads and all the normal stuff you expect to see in a heating system. So that's just a little bit about what we do. We've been dealing with the government scheme on one scheme called the Renewable Heat Incentive, also known as the RHI. And this is a scheme that pays homeowners back money for putting in a renewable technology. So many of you have probably heard of being paid to put solar on your roof. This is an equivalent scheme, really, slightly different calculations and methodology used, but a slightly different scheme where you put heating replacement boilers. So as was just pointed out there, if you joined early, Philippa was talking about gas boilers being outlawed in new build properties in the next 4 or 5 years. That then will pass through to existing properties where they'll outlaw fossil fuel. I don't know when that's coming in. I know new build regulation is in 2025. I would imagine 5 to 10 years after that, then fossil fuels will probably be outlawed to also other than specific premises that have no other option B. So I'm going to talk a bit about the renewable heat incentive, and then I'm going to talk about the Green Homes Grant. Then I'm going to go through the different technologies and backlink them to what grants are available and what you can get hold of. So hopefully we'll go through the grants and the process as much as we know on the new Green Homes Grant. Then I'll go through briefly the technologies. I'll look at things you should look for in your own properties, things to remember, things to think about, and then I'll leave you with a load of different email websites to visit that can sort of get you along that process, where you can really uncover a bit more about it and learn more. I'm guessing there'll be an option to also give you email address and phone numbers if you wanted to speak to one of our branches as well. So we're very much in the consultation with consumers. We work alongside them with their projects and help them realise really and advise them on the best methods to use and products to use for their property. So we're not tied to one type of technology. We do everything. So hopefully I've got a good spread of knowledge that I can hopefully pass on to you to make some decisions. So firstly, I'm going to look at the renewable heat incentive. And although many of you, I'm sure, are here for the Green Homes Grant, I will go through this as well, because actually the renewable heat incentive that has been live for domestic properties since 2014, and it was late to arrive, as is the new Green Homes Grant so far, but it was came in 2014, and the way that works is fundamentally, depending on the technology type, and it encompasses heat pumps, solar thermal, and biomass in the main. Those 3 types of technologies, if you put one of those into your house, depending on some other factors, and EPC is one of them, and I'll go into a bit on that at the end, you can get paid, and here's some sort of top line figures for you, because they do cap the payments. In terms of an air source heat pump, you'd receive around about £10,000 to £11,000. In terms of a ground source heat pump, you will receive back from the government in the region of £32,000 to £35,000. For a biomass boiler, you would receive back from the government around about £12,000. And for a solar thermal system, you'd receive back from the RHI round about £2,500 to £3,000. So that's some grant monies, and if you've got any questions, I can sort of go into more detail if need be. So that's some money available. The way it works is you need a few things. It needs to be an MCS installer. They need to use MCS products, and they will sign off with what's called an MCS certificate. MCS stands for Microgeneration Certification Scheme. So providing you go to an MCS installer, they will only install MCS products, and you will get this money back. It's government backed, AAA rated, which means fundamentally, once you're on the scheme, you're locked in. That's it. They can't renege on it. Otherwise, you could take them to court and win and sue them. So they don't renege on these things and never have. So once okay, I've just answered that, Carmen. MCS is Microgeneration Certification Scheme. So once you go through the MCS installer and get one of these technologies, during the official contract, you will receive a performance estimate, and this will tell you how much it will cost to run, the savings over your current system, the CO2 output, if there is any, of course, also how much money you will get back. This forms the your contract. So we've done hundreds and hundreds and hundreds, and we have had 100% success. So that part will happen. A lot ourselves and many companies out there do a complete hand-holding service, and once users right from the front in the design and consultation right to the end where it's installed and signed off, this is all really done for you. Just sit back and choose your supplier, really. So that's the renewable heat incentive in a nutshell. It can become lower the smaller the property, the less energy you need, because it's based on a deemed energy use of the house, as shown on the EPC. That's how much. So smaller houses, you'll probably get a bit less, but smaller house, it's a lower install cost, you'd hope. So they're the fundamentals of the renewable heat incentive. You can learn more by visiting Ofgem website, which is ofgem.com, I think, maybe co.uk, the Ofgem website, and you can visit there. They've got a whole tab on energy and the domestic RHI. So you can read all about it there. They've got quick handy guides. Alternatively, you'll see, email us at the end. So the Green Homes Grant Scheme, and I think this is what has stirred a lot of interest. Certainly we've seen a massive uptake in Green Square businesses. The Green Homes Grant is up front. So whereas the renewable heat incentive pay you at the end of the installation, and it's paid over 7 years, it's paid quarterly directly by Ofgem into your nominated bank account when we register it with you, and that's paid directly and it goes up by inflation every year. It's a fixed amount. That's what you get, but it is paid for 7 years, so it's quite a long payback. They picked the 7-year terms because that's the average length someone stays in their house for in the UK, or it certainly was when they started the scheme. So the Green Homes Grant is slightly different. It gives less money, but it gives more up front, up to £5,000 or 2/3 of any technologies. That increases to £10,000 and 100% of the cost if you're receiving benefits. Again, I will point you to the website and where you can find all this information and check your eligibility. But providing you're a homeowner or a landlord, you are eligible. So the Green Homes Grant, you go onto a website called, and again, I'll repeat all these websites, so if you haven't got a pen and paper, don't worry too much. But it's called www.simpleenergyadvice.org.uk. You visit that, right on the home screen there, they've got all about the Green Homes Grant. They're calling it the GHG. They're all about the Green Homes Grant, and you can click now. You can go through the process. It'll ask you some details about your home, answer as best you can. It may have an EPC logged online, so your house may have an EPC, you just don't know about it. I will tell you where to find that information yourself for free and instantly. But it will pull in as much information, ask you questions about your home. Then it will give you a list of measures that you can do in your home. It will give you some suggested cost prices for the type of technology. It will also give you a list of approved companies who can carry out this for you. So obviously Green Square will be there if you're looking at anything to do with renewable energy, but it will find the ones like nearest to you. I tell you now, certainly in the Guildford Surrey area where this meeting is taking place, there aren't that many. But we would always advise you should get more than one quote. That's not to say you should always go with the cheapest quote, but you should definitely get more than one quote just to ensure you're getting an absolutely fair price and you understand who you're going into bed with. But also, it is important as well to look at the value, because you do need, sorry, Carmen, quite right. I read that you need 3 quotes as well. I also know that isn't always possible without dealing with someone who is out of your area by up to 100 miles, I also know that those very same people who are 100 miles away are never going to come round your house to do a survey to give you a quote. So what you will end up with is a load of estimates. I don't know the process that the Green Homes Grant scheme is going to go through to check those. I understand you need to put in the name of the supplier and the cost. What I don't understand is who chooses once you put in those and so forth. So that's still very much a grey area. And actually the industry is asking a lot of questions around that. I've had a few returning customers who are now looking at the Green Homes Grant to add on technologies, mainly solar thermal, to us, and they only want to use us because we know their system, we understand it, they've used us for years and we still service their machine, and they will simply not deal with anyone but us. I don't know whether they'll be allowed to or not. I don't know the rules around it, but they will become clearer apparently on the 30th of September. But you should always get as many quotes as you can as well, of course. So the Green Homes Grant, then, I believe you will put in the information. The Green Homes Grant then issue this voucher. Now, all I do know is that this voucher is redeemed via the installer, who must be suitably qualified. The most important one, actually, for the voucher is the Trustmark scheme, the government endorsed Trustmark, which is owned by Trading Standards. Of course, again, we're a member, as you'd expect. So we, as an installer, and this will follow for whether it's cavity wall or any, but as an installer, they will have to then register their installation on your property with Trustmark, and Trustmark at that point will then, in effect, pay us. Actually, that, from a business perspective, that actually does open up a lot of issues for us, but from a consumer perspective, that's how it would work. So arguably, if you're getting quotes at the moment, 1/3 of that quote would be your deposit, I would imagine, and the 2/3 then would have to be paid by the installer. This will bring problems, I'm sure, certainly for this, actually doesn't affect us, but for the smaller installers, who, you know, that they'll be paying for the goods up front before they've been paid for them. So I can see some potential issues with that. So I would also urge anyone doing it to ensure with any supplier that the only money they will pay is that third. If they're asking for more and then want to give a rebate, I'd advise not to really deal with them. So the Green Home Grant scheme covers two different types, primary and secondary. So with primary measures, it covers insulation, and the insulation it would cover would be loft insulation, cavity wall insulation, solid wall, internal, external insulation, and floor insulation. I think there might also be flat roof insulation. They're a primary measure. Again, you'd go through the Simple Energy Advice website, you'd put in your details, you'd contact some local approved suppliers, you would get a number of quotes, you would then put those costs in. I'm guessing, because no one knows, Simple Energy Advice will approve those for you to then move forward with that installation. The other primary measures, other than insulation, is renewable technology. The renewable technology it covers are 4 types: air source, ground source, solar thermal, and biomass boilers. So that's not wood stoves, open fires, it's registered MCS biomass boilers. So if you wanted to look at specific brands, and I wouldn't suggest you want to get too caught up in that at the moment, but again, you could go to the Microgeneration Certification Scheme website and you can search products by category type and so forth. That will then take you to the manufacturer's website and you can look at the products. I wouldn't at this point get too tied up in what brands are being used. Just look at the viability first of all. So once you've chosen those primary measures, you could choose 2 primary measures, but the primary measures, there is a good chance that actually that could swallow quite a lot of the grant and you may never have then any left for secondary measures. The secondary measures, however, you can only tap into the grant money for them if you have used one of the primary measures. So fundamentally, any primary renewable energy measure other than solar thermal you're going to swallow all that grant money. So if you were looking for air source heat pump, for example, or a ground source heat pump, I would suggest don't start spending the money on some of the secondary measures, which are double glazing is one of them, draft proofing is another, and heating controls is another secondary measure. The first thing I would mention is if you are having a new air source or ground source or a new boiler system, those heating controls are all going to be dealt with in that installation anyway. So that would negate that. The draft proofing, I would personally highly recommend that if you're any good at DIY, this can be done relatively inexpensively by yourself, or certainly if you're handy. And the double glazing, I think, is a great. I think the double glazing industry is quite excited about that, and I think that's a good, a nice little grant. But again, you can only receive it if you've used a primary measure, and if you're using a renewable technology as a primary measure, bar solar thermal, it's going to swallow all the grant money. So the measures that they look at with the grants are, as I mentioned on the renewables, is air source, ground source, solar thermal and biomass. I'm just going to focus on solar thermal as the option at the moment, and there's a reason for that, and it's because firstly it is relatively, compared to the other boiler systems, inexpensive. Why? Because we are adding something to an existing system rather than removing an existing system and putting in something else. So it is the easiest option, providing you have got an area to put the panels, and the panels, solar thermal panels, there's two types. I'm not going to get too into them, but there's, I'm sure you've seen them on roofs. One just looks like a big flat black solar panel. Fundamentally, it's slightly different from your electric producing panels, but it's about 2 meters by 1 meter. It can go portrait or landscape, providing you've got space for 2 panels, maybe 3 on a larger house with a higher use, then they'll fit pretty much anywhere. Flat roofs, pitched roof, the important is we want it southerly facing. If you've only got north facing availability, you're just wasting your time by putting solar thermal on. I wouldn't advise it at all. So providing it's flat, we can angle it directly towards the south on angle plates. Alternatively, it's on a pitched roof that's southwest or southeast, south facing. Brilliant. That will save you solar thermal. A typical 2-panel, 3-panel system on a south facing roof with a decent cylinder size would save you in gas charges, if you're on gas, around about 120 to 150 pounds per annum. If you've got electric heating, you could pretty much double that. It's saving. If you're on LPG or oil, you're somewhere in between. So pretty good savings annually. The typical cost of a solar thermal, there's 2 things we need. Firstly, there's a roof to put them on that's south facing. The second thing we need is a water cylinder. Now, there's a good chance that everyone listening online at the moment has got either a combination combi boiler, or they have an old system with a airing cupboard with a small cylinder in it that's maybe 20, 30, 10 years old. If you've got either of these, then you will need a new cylinder. It's important that you have what's called a twin coil cylinder, or a solar cylinder, some people call it. Fundamentally, it's a twin coil cylinder. They're indirect cylinders. And this is because we've now got 2 heating sources. One is your traditional boiler, gas, oil, whatever it may be. The second is now the solar thermal. We need to separate them because the solar thermal panels sit outside. They've got antifreeze in them. So what we don't want to do is put in antifreeze all around the system. We want to confine it just to as small as we can. So it's literally in the panels and in this coil in your cylinder, not touching any of the other water. So the solar thermal system, I'm going to give you some rough costs here, and obviously this is all subject to site surveys and so forth. But typically speaking, if we were installing solar thermal into a cylinder that could already take solar thermal, maybe you knew one 3 years ago and you future-proofed it, typically about £4,000, £4,500, depending on access, do we need scaffolding. So around the £4,000 to £5,000 mark. I think this is also very similar to the energy savings advice, simple energy advice rather, website also gives that sort of mark, and it is around area. If you need a new cylinder, and you need a cylinder for solar thermal, so if you do need a cylinder either to add to your combination boiler, and they can be added, combination boilers, or to replace your existing cylinder so you're ready to take solar thermal, that is going to increase by around about £1,500 to £2,000. Again, depending on locations and stuff, how much pipe you have to run, what do you have to rip out, how easy is it access, and all those lovely things. So if you were looking at a new system and you needed a new cylinder, you're looking around the £6,000 mark. Equally, if combination boiler, roughly the same kind of money. At the end, if you want to know how it works with the combination boiler, I'm happy to go into the technicalities, but suffice to say, it does. You will need an area to put the cylinder. The cylinder size is typically going to be between 200 and 300 litres for your typical 4-bedroom house. The cylinder diameter is about 600mm diameter, so about a 2-foot diameter around it, and approximately about 5 foot high. So approximately you can fit in an airing cupboard. Now, good question just came up about an east-west array. Yes, you can fit them on an east-west array. Actually, one on the west and one on the east, panel on the east, would create about the same as 1.5 panels on the perfect south-facing roof. So actually costs a little bit more for an east-west array because we've got double the amount of fixings onto the roof. As you can imagine, we've got double the amount of pipework coming from different directions. We've got specific diverter valves, slightly upgrade on the controller so we can look at a lot of different things. But fundamentally, an east-west array is maybe £500 more than your kind of perfect southerly array. But other than that, they are quite affordable. It doesn't knock it out. So for if you need a new cylinder, you're looking around 6,000 for a sort of 2-3 panel system. Again, a lot of ifs and buts, and you're looking maybe 6.5 to 7 for an east-west array. Really will depend on the size of panels. Do we need scaffolding? Where's the cylinder? Do we need to add a cylinder? And so forth. So I can't even read that, but if I could, it would be, can solar thermal panel use to create a carport roof? Good question. Yes, in a word. Providing it's structurally sound, providing, obviously you want to think about things like shading. Providing things are sort of 10 metres plus away, it's okay. A lot of people sort of stand in front of trees and go, well, it's no good here because look at this tree. You go, yeah, but your panels are 20 metres away. Walk back 20 metres and you'll see the sun, you know, from sort of April through to October when you're getting certainly 80–90% of all the energy. So yes, they can be used on solar roofs. They can be used pretty much on your garden, at the back of your garden if you so wish. Just be aware, if you've got a listed property, if you're in an area of outstanding natural beauty, a conservation area, you will need approvals. The good news is that if you are in a conservation area of outstanding natural beauty, other than trying to fill your front windows with solar panels and totally change the appearance of your house, they're very pro doing renewables. So in terms of heat pumps, solar, any of these items, they want to conserve the area, so that they know in order to conserve, we need to be sustainable. Listed buildings slightly different, but still they are sort of changing their approach to things as well. So they can be used anywhere. The location of the sort of controllers is going to be next to the cylinder. So really just need to think about, if you wanted to think about this yourself, is wherever the solar panels are going to go, and they can pretty much fix anywhere, wherever they go, we need 2 pipes from there running to where the cylinder will go. So if you wanted to have a think about that yourself, please do. But we would always want to do a technical survey, and any installer will always want to do, or should always want to do, a technical survey before taking any money, because you want to be sure that you can stand by what you say you do. So that's solar. I'm sure there might be a few other questions. I'm happy to delve deeper. The other technologies then, oh, good question. How long does a Green Homes grant run? It runs, and the vouchers need to be redeemed by March the 31st, 2021. if I tell you that this 2 billion, £500 million of which could actually go into local councils for social housing. So we've got £1.5 billion really for domestic private sector. There aren't enough installers in the country to realise that 1.5 billion. I don't think we will even go through £500 million within that time. There's simply not enough installers to carry out the work. So I wouldn't worry at all about the budget running out. We're not even going to touch it. In fact, the budget for the Green Homes Grant over the next 6 months is 300 million higher than the total renewable heat incentive budget over 8 years. And of that renewable heating incentive budget over the 8 years, we're about 6 years in and we've used only 60% of it. So there is no way on earth that we're going to use that budget. Don't worry about the money budget running out. Definitely worrying about not finding an installer qualified to be able to deliver it for you. So another quick question is about the solar thermal, which is on the cylinders. They can go in loft, but we need to make sure structurally it can take the weight. If you look at, for example, a 300 litre cylinder, that is going to weigh in total about 350 kilos. So you may need some structural support. The cylinders can lie horizontally, and they're not quite as good at stratifying horizontally, and don't really like them for solar, but they are doable. We can also make a slimline, which are about 480 mil diameter. I'm within an inch there, about 480 mil diameter. Again, they can only make them in a certain size because their height to really depict the maximum size. So typically on a slimline of sort of 480 wide cylinder, you're looking at maximum 250 litres. I don't even think they can do 300. The reason being, of course, if you go too long and thin, the pressure of the water and it starts to bulge. So we're kind of dictated by physics. But they do a slimline model. You can fit them practically anywhere. You don't really want to put them outside, of course. You want to keep them in an insulated area so we retain as much of that heat as possible. But they can go on lofts. You may need to double up joists and put some extra support in. But fundamentally, they can go on any floor level. The other thing to consider when looking at solar thermal is many of you will be on what's called an open vented system. If you want to know whether you're on an open vented system, it's very easy. Look in your loft. If you've got a black plastic bath type container, and maybe then a smaller sort of foot cubed black plastic container, you'll see like a toilet system with a ball valve in it that's full up with water. This is an open vented system. So if you've got your loft with a big water case, and maybe then a smaller one will be somewhere as well, yeah, you've got an open vented system. We would typically move to a pressurized system. So everything, all the pressure in the taps and the showers are on mains water pressure. Sometimes the pressure is awful at properties, and actually you prefer an open vent because you can pump from an open vent, whereas you can't pump when it comes in from the mains. We can do either. So this is, again, any installer would look at this pre-installation to ensure that we had the right models and it could deliver the power of water you want. If you've got particularly poor water, you might want to boost this. We do booster sets as well, just if you like a power shower, for example. So that's solar thermal. I'm sure you've got more questions, but just for time, I better move on. So with the other one I'm going to touch on is biomass. So biomass is good for high temperatures. Is if you're off grid, it's a good option. If you're on oil or LPG, the running costs of biomass are currently quite high. They use pellets. Again, I don't want to be dragged into the intricacies, but it's quite a lot of manual input. If you were on electric and lived in a very old drafty building and didn't have a great power supply and 100 other reasons, but very specific, maybe biomass would be for you. It's not something we kind of go around. We're all qualified to do it and we're under MCS. It is very unique where we would really feel comfortable doing it. There's a lot of interaction. They need cleaning every week, and the servicing is quite high on them. It beats night storage, but it doesn't beat an air source heat pump or a ground source heat pump or gas boiler, a mains gas boiler, in terms of practicality. Obviously, they're carbon neutral. You buy pellets in, you buy them on a pallet, you can have them blown in. There's lots of different ways that the pellets can be delivered. The boiler's automated, or it can be manual. There's many different sort of configurations, but fundamentally biomass is burning wood. The wood is reclaimed. We're not chopping down the Amazon to make pellets. This is just a fallacy. American pellets don't exist in the UK, so it's just not something that's happening. 50% actually of pellets come from Scottish timber mills, reclaimed sawdust. So the fact that people are mining expensive oak trees to then put them into the lowest possible commodity they can is just a fallacy. It's waste wood in the main. It's the cheapest wood you can buy, chipped up and then compressed into pellets. So biomass may be for some people in very specific areas, but overall, I'd suggest that air and ground source are better. So air and ground source, they're very similar. The difference between the two technologies, of course, is where do they get their energy from? One gets their energy from air, the other gets their energy from the ground. Ground source have pipes in the ground. These may go boreholes, and these boreholes, I think the deepest we've gone is 150 metres. You struggle to go over this on the borehole because they don't have the lengths to get down there, but typically between 80 and 150 metres. Geological studies are done beforehand, as you can imagine, and we look at the thermal conductivity. Very average. The ground temperature is pretty much an even 14 degrees all the year round. So there's our source temperature. Air temperature, as you know, can fluctuate from month to month, season to season. So it can be anywhere from -5 degrees maybe, if you're very rural and high up, to 35 degrees. So we've got a much wider fluctuation. What that means is that the efficiency of the air source heat pump is not quite as much as the ground source heat pump for heating on average over the year. Why? Well, when you use your heating, the air source heat pump, of course, sources the air. And when you need your heating, it's cold outside. So the efficiency of the heat pump on, let's say, a New Year's Day, and it's -2 outside, and you want to be 21 degrees toasty in the house, the heat pump will provide that for you, and you will be warm in the house if designed correctly. But what it can't do is be super efficient at those temperatures. Its source material, -2. Its temperature it's trying to drive at actually is the water temperature through your radiators or underfloor, which on radiators is typically going to be around 50 degrees. So we've got quite a big delta T there. Ground source, however, well, that's starting at 14 degrees. So straight away, we've increased efficiency. So a quick question on the voucher. Yeah, you get 5,000 or 2/3, whichever is the a lower amount. So it's 2/3 up to grant money of £5,000. Unless you get the £10,000, of course, then it's 100% funded up to £10,000. So the way a heat pump works is you think, well, how can I get energy, for example, out of air when it's -2? Well, it's very simple. It uses the second law of thermodynamics, which we're all familiar with, which is basically you will always find an equilibrium, which means when you have two temperatures, the hotter temperature will always pass energy to the colder temperature. So if we want energy from -2, I need whatever I put next to it to be colder than -2. Providing I went out with a block of ice that was -10 degrees, if you could ever do that, a -10 degrees block of ice, over time at -2 outside, that block of ice would slowly warm up to -2. That's how we get energy out of both the ground and air. We can, a good demonstration, of course, is the bicycle pump. Lots of people have heard this now, I've been bleating on this for about a decade. You put your thumb over your bicycle pump, give it a pump, and your thumb feels like it's burning. Well, it is. Why? Because we've just compressed the air from there, and we've compressed it down into that small little bit that just squeezes out past your pump, your thumb. So why is that hot? Well, we're taking all those atoms and stuff and compressing them down, and now these atoms are going crazy, moving about, creating energy, which in turn is shown as heat. We do the same thing, but the medium we use in order to compress isn't air, because it's pretty difficult. You've got to use quite a lot of energy to compress air. There's something called refrigerant, and you'll find refrigerant in the back of your fridge. And refrigerant is a medium that can be heated and cooled by compressing and contracting, and it's pretty easy to compress and contract in the big scheme of things. You could do the same with water, of course. Compress, go up a mountain, higher altitudes, it boils at a lower temperature. It's exactly the same principles. It's just the medium refrigerant is just very easy to do compared to other materials, which is why they use it. So we get this refrigerant and we expand it. So we're getting this block and we're expanding it. So all those atoms now are slowing right down and getting colder. We then pass those across the energy of the air or of the ground. So we pass that energy of the air of the ground, and then we've captured some energy. So now this energy in the refrigerant, we're going to compress. So it gets hot. All those atoms, as we push it together, we get hot. We then use that heat, bring it into the house via radiators, into your domestic hot water cylinder for your baths and so forth. So now we've just stripped that refrigerant of heat. We stretch it out again, we uncompress it, and it gets really cold again. And we send it back outside to go and pick up some more energy. Picks up some more, we do the process again. So this is what's happening with air and ground source. Now, the fundamental thing to understand is for every 1 kilowatt of energy, electrical energy, we're using to compress this refrigerant to get the heat up so we can use it. For every 1 kilowatt of electricity we use, we can create anywhere between 3 and 5 kilowatts of thermal heat in the house. So you could view this in simple terms as an efficiency. So if your gas boiler on average over the year is about 80% efficient, an air source heat pump over the year is on average 350% efficient. A ground source on average over the year is maybe 450. We've even had one at 500% efficiency. So on average, for every 1 kilowatt of electricity you buy, you produce 5 kilowatts of thermal energy. In comparison, to create 5 thermal kilowatts of energy using oil, I would have to use 6 to 7 kilowatts of oil, which in real terms is about 700 millilitres, or if you like, 40p worth, 40p's worth to get 5 kilowatts in the house. With a ground source heat pump, under those circumstances, based on 15 pence a kilowatt hour, you would pay around 3 pence. 15 divided by 5, 1 in, 15, 5 out. To get the cost per one, we're looking about 3 pence. So if the cost for 5 kilowatts would cost you about 15p. So against oil, in those circumstances, you're going to be about 60, 70% lower running costs on average over the year. So an air source heat pump has 3 main bits of kit. It has the outside unit. This looks like an aircon unit, and typically about 1 metre wide, 1 metre high, and about 400 millimetre, 40 centimetres deep. The thing to remember about air source heat pumps, where the fan is blowing the air away, you do not want to put an obstruction in front of that. You want that air to move as far away from the heat pump as possible. We do not want to recirculate that air. They can sit on a wall, they can sit on the ground, they can sit at the back of the garden, they could sit pretty much anywhere under permitted development. So under permitted development, there's 2 main rules. The first rule is the outside unit with the fan must be 1 metre off your curtilage or boundary. So you can't put it up to the neighbour's fence. It's got to be 1 metre within your boundary. The second thing to remember about air source heat pumps is that really you would, if you wanted to put them at the front of your house where it could be seen from curbside, you're going to need planning permission. It does not fall under permitted development. So provided you can get it down the side and you get it at the back, bearing in mind that we're 1 metre off our boundary and that we've got plenty of free area for the air to run away once it's blown out the front, then you're under permitted development, you're okay. When you get into bigger units or more than 1 unit, like a larger house, you might need a 3-phase machine or a pair of single-phase units. Then again, you'd have to go to planning. But fundamentally, for 80% of the housing stock, you know, one heat pump will do. Some people like it at the back of their garden; they don't want to see it at all. That's fine, but we would need to bring in some pipes, 2 pipes into the property, which adds on costs. And the benefit, I suppose, is not directly seeing it. But they can pretty much go anywhere. The golden rule is that providing they are within 20 metres of your cylinder, your domestic hot water cylinder, which is kind of going to be your hub, as long as it's within 20 metres, and that's not 20 as a crow flies, 20 metres, that's 20 metres worth of pipe run, then you're okay. So again, if you wanted to have a think about that yourself, 20 metres away in pipe lengths from the cylinder cupboard. Noise is another big thing that's asked about heat pumps. I would say, firstly, they've moved on a lot from 5 or 6 years ago. Secondly, we have to do noise calculations, and they're all recorded and stored and logged, so we don't do anything illegal, because if it or against regulations, not illegal. If they're against regulations, why? Because if we do them against regulations, we as the installer are legally obliged to move it and do it correctly. So there's no get out of jail for us. We want to do it correctly. We do not want to be coming back and changing things just to try and get away with something. So we always do the noise calculations. And we always meet permitted development rights, just so there's no issues, and touch wood, we haven't had any yet. So they're the things to remember with an air source heat pump. The siting of it, we prefer the floor to walls, because just in case there is any vibration or anything that develops, you just still won't hear it. That's the main thing. The other thing on the sound levels is you need to hear some. We've got plenty around this area you can go and listen to if ever you did. But they have definitely come down in volume. So if I tell you that the outside ambient noise level on any given day, on average, is deemed, if you like, by the council as about 41 decibels. At 3 metres away, outside, stood directly in front of the machine at 3 metres away, the nominal noise level is 41 decibels. So fundamentally, if you're 3 metres away, you won't hear it. Add to that a wall and a double glazed window, a metre away, you don't hear it. So the noise levels really have come down. I wouldn't fret about them. I spoke to a customer yesterday, in fact, they might be online, hello if you are, but talked about their neighbour's air source heat pump, 3-phase unit, I believe, on a swimming pool, and they could hear it 12 metres away. And my view was like, yeah, well, you need to go and do, they put something you're not allowed to put on, so you need to go and challenge that. I've got to say, our homeowners don't have any complaints. By far the biggest issue is the worry about the noise, 10 times more than the actual issue of noise. So I've never had to move a unit yet, ever. So again, we've done hundreds of them. So we will always make sure that that's okay, and we would always ask you to come and listen to. We've got in our showroom, you can come and listen to one. We've got plenty of sites where our customers are happy for us to traipse around some people now and again to go and listen to it. So I wouldn't concern yourself about noise with them, but do still check it out. You know, do your due diligence. So air source heat pumps, rough cost, and I know this is probably on everyone's mind. So there is a darn good chance you're going to need a new water cylinder. They're not combi. They don't, unlike gas boilers, you do always need a stored amount of water. Typically, they're different to your normal cylinder. They've got a bigger coil because they're lower heat. If you're on radiators, there's a good chance that you're going to have to upgrade some of the radiators. We guarantee, look, if you're worried about radiators, we pretty much guarantee you will not be replacing. The maximum you will generally replace is 50% of them. That's the worst case that we've ever had. You may choose to change more, that's fine. But generally speaking, providing they're all in good working condition, we would always be looking to use them elsewhere. And that's both for air and ground have those similar challenges. I would urge you to go on eBay and look at the cost of a radiator. They're tens of pounds. I wouldn't let that stop you. The bigger the radiators we get, or underfloor heating, even better. But the bigger the radiators on underfloor heating, yeah, great. You're going to get really good efficiencies. Servicing on them, minimal. It's a bit like servicing a TV. There's not an awful lot we can do. It's an electrical item. It's all enclosed. We give the air source heat pump a darn good wash. And that is pretty much about it for the air source heat pump. There's a small filter in there, a Y strain, a standard, just a filter that we just sort of protect the boiler, that we just clean out. That's it. Really, we're checking settings, we're checking performance, we're checking efficiencies, and we're checking, most importantly, safety devices. So things in the house actually on your cylinder, like the temperature pressure relief valve and all the safety, mechanical safety protection that's going to be involved as well. Not that they can get to the temperatures where they'll ever be realised, but it's all part of the regs. So maintenance, we charge all our air source heat pumps, we charge £100. And we come to this charge because really that's the cost to call out, be there for typically 45 minutes to an hour, and go again. So it's the same price as a gas combi boiler service, very similar costs. The warranties you get on these as well will largely depend on the brands you use. We give, on our preferred brands, we give a 7 years parts and labour warranty. This means everything's covered for the complete term of the renewable heat incentive. So their heat pumps. Now, ground source, really touch on ground source. Sorry, the three main bits of equipment, I've got this written down. The three main bits of equipment, fan outside, we've got your domestic hot water cylinder, you know what they look like inside, and we've got another cylinder, much smaller than a domestic hot water cylinder, typically a 400 diameter, typically 50 to 100 litres, so not massive. These can go anywhere in the loft, doesn't really matter. We want to keep it close to the cylinder just to save a bit of money on pipe work. But fundamentally, this is on your heating side and it's on frost protection side. What we don't want to do is put glycol in your system to save against frost, because this increases the service charges. So for the, I don't know, they're about £200 for a little cylinder. For the cost, we put it in, it just protects your system. Also stops it cycling, which makes it a bit more efficient. And I'm reading text, and but they can go anywhere in the city. So if you think I've only got one cylinder covered, providing you've got a space to fit something the size of a standard vacuum cleaner, you know, you'll have enough space. It doesn't take up much. So they're the three main bits of kits. The rest is pipe work and pumps and standard stuff that you see on a standard thing that attach to walls on the standard heating system. Ground source heat pump, three main units. It's got the two cylinders again, your domestic hot water and this small buffer cylinder. You've also got the ground source heat pump unit itself. The size of this will be footprint 600 by about 620. In other words, every ground source heat pump I've seen has been made the same footprint as a washing machine, a dishwasher, for a standard UK kitchen. Why? Because it can go in a kitchen. I wouldn't put it in a kitchen, but they are built to go in kitchens. They're great for utility rooms. That corner of garage, shed outhouse, doesn't really matter. This is the ground source, and this is fundamentally doing all the work and producing all the heat. From this unit comes two pipes, which then go to boreholes or a horizontal loop, which is fundamentally up and down, metre down in your garden, metre apart pipe that go up and down. You need a big garden, ideally a field. It does get chewed up a bit. Drilling, we just go straight down. It does still chew up your garden, but maybe over a 4 square metre area rather than a 400 square metre area. And also there's trenches between the boreholes as well, but less mess with boreholes than having to do trenches, but still a fair bit of mess in your garden. Of course, grass grows back, so it's not a permanent problem. So ground source heat pumps, their unit is typically about 6 foot high, 5-6 foot high, depending on the size, 600 by 620 teeth, and then you've got your two cylinders again. So still 3 units, all the pipe outside buried, you don't see it. So in terms of cost, and this is a bit of how long is a bit of string, but if I just look at your typical 3-bedroom house, a typical 3-bedroom house for a new air source heat pump system is typically going to cost you anywhere between 12,000 and 16,000, and I'm covering all the ranges. So for a big old boiler, maybe a 4-bedroom detached, we're up towards a 16,000. A 3-bedroom semi, we're down towards a 12,000. So that's kind of the rough range for your average type of house. The money coming back from the government on the renewable heat incentive, 10 to 11,000. So actually a good proportion of that cost is taken up. With a ground source heat pump, much more expensive. So a ground source heat pump to install with boreholes we're again typically looking from 30 up to £50,000. A large proportion of that is on the ground external works, but 30 to £50,000, depending on, again, on the size of the property, and actually it depends on what we find a metre down or 100 metres down. So it can have quite a lot to do with the geological survey. The money coming back from the government under the renewable heat incentive, £33,000 to £35,000. So yes, there is quite a big outlay, but actually, yes, there is quite a big return. Ground source heat pumps are the best. In other words, they are the lowest running cost, most efficient, durable, bulletproof. Remember, all the collector here is buried sometimes 150 metres down. This is, they'll go on forever and ever. The life expectancy you can expect from these 15, 20 years upwards. With ground source, I'd even suggest more. So a lot of our companies, one of our companies that we deal with is a Swedish company, and they have been established 33 years. The first heat pump they ever made is still running and still as efficient today as it was back then. Arguably, the newer heat pumps are more efficient today than that one, but the fact is it's lost zero efficiency. So they really do keep going. Actually, the cost of replacement parts, first of all, with the 7-year parts and labour warranty, you just don't need to think about. But the cost of parts is only 2 moving parts in an air source heat pump. There's a compressor and there's a fan. The fan, if I tell you, is less than £100. So there's one bit. The compressor, several £100. Again, touch wood, I've never had one go on me yet, but that, I suppose they could go. To understand the reliability, I would liken it to the fridge uses the same kind of compressor, smaller, but the same thing. Fridges do go, but actually it's not uncommon to see a fridge 30 years old still chugging away. And it's the same with an air source and a ground source heat pump. On the ground source, of course, is just one moving part, the compressor. So in terms of replacement costs, one, they're very bulletproof. Remembering air source heat pumps are built to go outside for over a decade. I can see some questions coming in, and I will get to them, I assure you, but I just don't want to lose my train of thought. So we've gone through some of the technologies, I've hopefully gone through some of the costs. I'm just going to now touch on how the Green Homes Grant and Renewable Heat Incentive work together. So let's use an example of you want a new air source heat pump, you're on oil and you want to lose the oil, it's costing you too much and it's horribly on the CO2 levels, and you want to become zero carbon. So we decide upon an air source heat pump. You need maybe a 12 kilowatt air source heat pump and a new domestic hot water cylinder, and it's going to cost you £13,000 to install that and supply and install that. The RHI would give you £11,000 back. So net, that's costing you £2,000. Now the Green Home Grant links into that by saying, well, we know you're getting £11,000 back. We'll give you this £5,000 up front, but then we're going to remove that £5,000 from the renewable heat incentive. In other words, the Green Home Grant, when looking at air source, ground source, or biomass, I'm going to leave solar thermal out because it doesn't, brings you no financial advantages in terms of the return on investment. All it does is helps you with that upfront cost. One could argue that the Green Homes Grant scheme isn't a new budget at all when it comes to renewable energy. All they're actually doing is nicking a bit of the RHI budget, and rather than giving £5,000 of it back to you over the 7 years, they're just moving it into the front end, calling it a new name and applying a new budget to it. So there is no financial advantage over the 7-year period to use the Green Homes Grant or not use it. It makes no difference to an installer, of course, but to you, it obviously helps with that upfront. If that was all you were doing, I would certainly say take advantage of it, because you know, if you can not use some of that upfront money and put it in a bank, great. You're making interest on that. But if you think, well, I need some insulation and I want to get an air source heat pump, you are much better financially to use the Green Homes Grant on your insulation, where there is no already some grant in place for it than you are on the renewable heat incentive technology, i.e. air source, ground source, so actually not solar because I'll go over that, or biomass. So the Green Homes Grant is great for helping with some upfront payment, but actually in terms of total payback over the 7 years, the renewable heat incentive is already there. So it's not Green Homes Grant and it's Green Homes Grant then reduced from the RHI. The reason why solar thermal is slightly different is because the RHI on that, as I mentioned earlier, is typically £2,500 to £3,000. Well, actually, what we can is less than if it was a £6,000 install, £4,000 up front. So the Green Homes Grant is great for solar, but, and this is pretty exclusive, but there is a way where you could, if you wanted to really do your bit for the environment, is use solar thermal alongside an air source or ground source or biomass. So how that would work is, well, you'll need a new cylinder with solar thermal. But if we, of course, encompass that in the solar thermal cost and a couple of other bits, your solar thermal cost would probably go up to about 7,500, of which you get 5,000, of course, from the Green Homes Grant. But the cost of the air source heat pump would actually come down to around 10,000, of which you're going to get 11,000 back. So combining solar thermal and either a ground source, an air source, or biomass boiler will actually give you more benefit. So typically, if we were to use, let's say we get 11,000 back on RHI and we were having a solar thermal install alongside an air source heat pump, so now we're really saving money now over your running costs, and you are zero carbon. This is as good as it gets from a carbon and money saving point. Those two together, a combined total cost would be around £17,000. The money you'd get back for those would be £5,000 from the Green Homes Grant and up to £11,000 back from the renewable heat incentive. So the total grant money available on that system would be about £16,000, and it would have cost you £17,000. So net cost for an air source heat pump and solar thermal, there's some physical things to do, but I've done these quotes, so I can accurately show you actual live quotes out there and orders actually already or based on this. Your net cost for a complete new heating system would net over 7 years cost you about £1,000 to £2,000. Now, your running costs would also go down. Approximately, based on gas, which is the cheapest you can get, it's going to go down about £120. Based on oil, you're going to go down about 30–40%. When you add those up, those yearly savings up over 7 years, you will arguably find that renewing your heating system with an air source or ground source, air source are the easiest, obviously, with an air source system and solar thermal, arguably, it's not going to cost you anything. At the end of the 7 years, you'll probably be financially better off than if you did nothing. You will be financially a lot better off if you then go out and spend £4,000 on a new oil boiler. So this is why our phone and emails are ringing and flying off. So there's, hopefully, I've given a bit of advice then, but I think if we flip to the questions, I can ask more specific ones and still keep asking them, because there's a darn good chance I've forgotten to do something. Now, I would love to see them, other than I don't know how to see them, Philippa. How do I have a look at the...
Okay, I'll just put myself back on. I'm just flipping up. Which ones? There was someone earlier worried about the strength of the roof, flat roof,
yep,
and how strong the angled fixings would be. They've got strong winds. Have you ever had, this is for the solar thermal panels,
yes,
have them blown off the roof?
Yeah, so this is, so if we were really, firstly, all the panels and their fixings, and we would always buy a panel with its own fixing because it's all been tested together, so you can stand by it. If you start going, well, we'll have their panels and their fixings, that's never been tested together. So the first thing, any decent installer will always get fixings that go with the panels and have been tested with the panels. Wind uplift is something that is measured. So this would all be measured within the report and taken into account. I can tell you, everyone's panels with their fixings, they've all gone through the wind uplift. I think it's measured to something like 150 miles an hour. They've all been measured. If we were unsure of the unit we were putting it on, we would need to get a structural engineer. So typically, we do like to put panels where we can in the roof. When I say in the roof, it fits a bit like a Velux window, but we put it in the roof, then there's no wind uplift. Also, when you take the tiles off, the weight of the panel is about the same as the tile, so there's no extra weight either. But structural engineers' reports for solar panels are really rare. So I've done 2 in the last 6 years. So generally you can tell by sight and eye, and you know the panel's been checked for wind. There'll always be extremes, and there'll always be, but we've never lost a panel yet. But I suppose it could happen. But we've follow the rules and you're okay. If we were particularly worried, we would get a structural engineer. As simple as that. So you should always, you should always be all right. More importantly, any company that you deal with, and again, I'm speaking for Green Square, you need to speak to others, will have insurance against all these things, including any monies paid and workmanship insurance as well. So Green Square, any money paid to us is all covered. So if anything should happen to Green Square, any money paid to us is all covered, as is all the workmanship covered if anything should happen to Green Square as well. So anyone you deal with will definitely go, it's definitely, you're insured to the hill. Consumer protection is a massive thing with both the Green Homes Grant and the RHI. It's massive. So as a consumer, trust me, you're in a really strong position from safety aspect. So it is a concern. It needs to be thought about, but these things are picked up on the surveys. As simple as that. So.
Okay. Thank you.
Okay.
There's another one. What happens if you move before the 7 years? What happens to the renewable heat incentive?
Yeah, so it moves on to the new homeowner. Simple as that. It stays with the house. So the new homeowner. So we've had a couple of these happen, as you can imagine, where we've done something that the people have moved out. In fact, we're just going through one at the moment on the south coast, where exactly that. You go on to Ofgem. Again, we do all this hand-holding service, but it's very straightforward. You go on to Ofgem, you tell them, you give them the new account detail, customer details. You tell them I'm going. They then write to the customer, the new homeowner, and say, right, this is available. You need to go on Ofgem website, put in your details, bank account details, and then you start getting the money. So although there is, people argue, go, well, I might not be in 5 years. No, I get that. You might move, but equally, you're adding value. There's value to it on your property. I mean, it's even now when it comes to energy performance certificates, that for estate agents moving house, they're starting to put value on it. When it's A, B, or C, they go, oh, this is great. There is value to it. I don't ask me how much, but there is definitely value to it. So it would pass on to the new homeowners, but there's not many places you can buy a house and get cash back on it. So I'd say it's a positive. I don't think, well, each to their own, but it does continue if you move house to the new homeowners.
Thank you. There's one that's storing surplus energy and selling it back to the grid with an ASHP.
No, it's no. So an air source heat pump, it creates heat. The things that create energy are windmills and solar PV panels. Winds are pretty much gone because you just can't get planning onshore. But solar PV, we didn't really touch on it because it's not part of the renewable heat incentive or the Green Homes Grant. But solar PV is, they do an export tariff. If you've got solar PV, they do an export. You can't really control when it's being exported unless you've got a battery and a smart energy controller. And we're adding on. This isn't for homeowners today, in my opinion. But PV is good. PV works well with heat pumps. We do plenty of solar PV. We started doing some batteries, but for Green Square, although we sell batteries, they're not something we would necessarily advise at the moment, because they're just not. They don't wash their own hands in money terms. If it's cheaper just to buy off the grid, why would you get a battery? Batteries are more expensive, so than if you just bought the power for 10 years. So there will be a point when battery storage with PV becomes, financially viable, but we're a year or two away from that, I think. So yeah, no, there's nothing selling back to the grid. The way they calculate how much you have, we talked about the energy performance certificates. On your energy performance certificate, the rules are for the renewable heat incentive, quite simply, is can't be more than 2 years old, the energy performance certificate, and you mustn't be recommended loft or cavity wall insulation. So if you need loft or cavity wall insulation and want to get the RHI, you're going to have to get them done. The reason for this, of course, is the RHI and the Green Homes Grant is our money, taxpayer money. So what they don't want to do is be giving out tens of thousands of pounds of taxpayers' money to you and I when you haven't done the simple things like put a bit, £100 worth of loft insulation in. So they're really just saying, look, this money's here, but we want to see that you've done the easy wins. I would say that, again, with the Green Homes Grant, those easy wins have just been made easier by 66% by the fact they're going to pay up front for 2/3 of it. One bit of advice I would give on that is that on the loft insulation, if you do need loft insulation, I wouldn't, one, it pays for itself super quick. So it's a really, if you just bought it and did it yourself, that's going to be cheaper than if you go through the Green Homes Grant scheme, depending on the size of the loft. If you lived in Buckingham Palace, I'll probably have a different view. But in your average house, if you do need loft insulation, then I would, if you can't do it yourself, then pay a handyman. It's 2 hours work on your average, £50 a roll. My view would be, don't pay someone who's going to charge 3 times as much because it's a government scheme to do something that you could do yourself. You do it yourself, you comply. There is no regs against how to lay loft insulation rather. So it's something you could do yourself. And that's what I would advise to do, because I think the amount you pay to do it yourself is probably the same amount you can pay someone to do it through the Green Homes Grant scheme, taking into account the grant. So unless you're, of course, on receiving benefits and it's 100% paid for, different argument. But for the average homeowner, I guess who's not on benefits, it's something definitely I'd advise. If you can get a handyman round to do it, there's no tools required, right? You just roll it out. So I would always advise, if you can, do that yourself, because you will just save yourself a small fortune there. And the Green Home Grant is better spent definitely elsewhere, in my opinion. So we have a ground source heat pump at work. The ground is guaranteed for 100 years. The ground source heat pump for 25 years. Brilliant, yeah, Carmen. That's yeah, I agree. I mean, the fact that they're guaranteeing the ground for 100 years, I mean, that's just poppycock, right? Because you can't get insurance to do that for 100 years. It's just, the point is, what they're saying is this will never go. It just won't. And I would argue the same for the ground source heat pump. Components might go. If I tell you the PCB board, these things you get for gas boilers, they seem to be hundreds of pounds on. It's less than £100 for the PCB board in the heat pump. And there you go. And this is based around electric. So actually, the prices are pretty. I think the units are still high. They will come down over a long period of time. But certainly the tech in them, they're being sensible with it, actually, compared to the gas market, in my opinion. So yeah, the ground source heat pumps are great. I mean, they are the best, but they do cost a lot. We'd all like one, we can't all afford one.
So about insulation, someone's had a loft conversion, which is very hot in summer.
Yes.
Does it mean that they're going to lose significant heat in winter, and tips to improve it?
No. Well, if they've got no loft insulation, it's difficult, that, because you've got to start pulling off plasterboard to get in between the sort of roof line and it's really not much you can do other than sort of bite the bullet and insulate it. The good news is the Green Home Grants will cover this. So 2/3 of the cost is covered. Again, this, when I'm talking about loft, do-it-yourself loft, I'm talking about getting the wall from the rock wall from B&Q for £29.99 a roll and just getting up there and rolling it out yourself. It doesn't need to be an art project. It's not, it's there to keep warm, providing you've got everywhere covered, you're done. When you've got room in roof, so we've got plasterboard, you really want a professional in to do that. But the Green Homes Grant Scheme will cover it. So that is the best thing to do as well. It does, just because it's hot in the summer doesn't necessarily mean though that it's not insulated. So I would certainly I'll get that checked out. If you know it's not insulated, then yeah, definitely insulate it. But of course, heat rises. Often when you do rooms in lofts, if you like, whether it's a chalet style bungalow or you're just doing loft conversion, those rooms actually they are, generally speaking, you don't put radiators, you don't need any energy in them because all the heat rises in the house into that area. Generally, where you have a loft conversion, the insulation is done so well that it just traps that heat in. Very few wind, generally speaking, in a loft conversion. You might have one dormer or maybe two Velux, or very small window space, which is not so great insulation. Generally speaking, yeah, loft. When you've got insulation in the loft, heat-wise, you don't need much at all. If roof house, yeah.
Are there any limits on secondary energy savings grant amount, and is it also up to 2/3 cost or full amount?
Yeah, again, so if you're not on the scheme, then there is no, the total limit is 5,000. So if, let's say, you needed cavity wall and that was £3,000, so they say, well, we'll pay 2,000, you got £1,000 for yourself. So you took that. You've now got £3,000 left for your secondary measures. So the total is 5,000. Again, if you're on benefits, it's 10,000, different calculation, it's 10,000, 100%. But for the 5,000, yeah, whatever you use in your primary is what's left of the secondary. But again, what I don't know, and these are some unknowns because I haven't released yet. What I don't know, if you say, well, look, we're getting an air source heat pump and we want that double glazed, we don't want to use all the Green Homes grant on the air source heat pump. I don't know how. I don't even know if that's an option or not. But whether you can yourself dictate how much of the Green Homes grant you want to receive, or whether it's just a flat 2/3. That's it. You don't get a choice to say actually pay a bit less so I can move a bit over. Honestly, I don't know. They haven't released it yet, so I'll be guessing. If I had to guess, I'd say no. They want you to do the primaries. The secondaries there, in my opinion, is there as a teaser to get you to do, the secondaries are there as a teaser to get you to do one of the primaries. So I can only really see secondaries being used for cavity or loft insulation. Once you get into solid floor or external, internal, you're going to use all that budget. So I can only see secondary measures ever being used if your primary is either loft or cavity insulation. I hope that helps.
There's the solar thermal system. Does it heat up just the water or the radiators?
No,
and
it's
also
just
radiators. Do you need a particular type of radiator?
Okay, so no, under the MCS rules and the RHI rules, and it can only do your domestic hot water. Now you can have solar thermal installed and to help run the radiators. I mean, the first thing I'd say is, look, when your radiators need it, the sun's not shining, so don't think it's like an answer. It's good for in the summer where you've created a bit of energy and you just want the heating on once the sun goes down, maybe. But it's not going to create a lot anyway. The reason they pulled it under the rules is what they didn't want people doing was putting 100 solar thermal panels in their back garden, hoping that they can reduce their energy bills in the winter. And then, of course, come summer, they've got 3 hot water taps running constantly all day because they're creating so much energy. So they basically put the regs towards only domestic hot water. Typically, solar thermal should do your sort of target would be doing around 60% of all your hot water on average over the year. Over the summer, it's probably going to do 80–85% of it over the summer months. But on average over the year, the solar good system will do about 60% of your total hot water. It's also worth remembering, of course, when you're doing hot water in the summer using a traditional cylinder system and a gas boiler, that gas boiler is hugely inefficient in the summer. Gas boilers are much more efficient in the winter when they're running. It's a bit like running a car on a motorway.
the longer you run and keep it at that same speed, the more efficient you are. Gas boilers are the same thing. So gas boilers are super efficient really in the winter, pretty inefficient in the summer. So actually you're saving with solar thermal quite a lot of inefficient, high cost gas use. So solar thermal is, you know, customers love solar thermal. It's something you don't get it too excited about, but it just works every time. It just works. It's more reliable than the solar PV even. They're super durable, super robust, and they just work. So yeah, they do 60% of your hot water, but no, you could use them for radiators, but you're forgoing all this grant money. I just wouldn't recommend it. For solar thermal, are there any tools online that estimate heat collected and financial aspects, and also with air source heat pumps? So with air source heat pumps, actually on our website, am I okay to promote it, my website?
Yeah, I think so.
Yes,
yeah.
okay. It's for a tool, I'm not going to, but so it's greensquare.co.uk, www.greensquare.co.uk. On there on the homepage, we've got a calculator, an RHI calculator. We're making a lot of assumptions, which is as much as you can. But if you put it in there, it'll ask you what fuel you're currently using, estimated kilowatt hours. You can put it in there and it'll give you an idea. It's not perfect though, because to get perfect, you've got to spend about 2 days to give you that proper information. There is for solar thermal. So air source is really difficult because you've got to do a complete heat loss survey of the whole house, which involves going around every room and measuring every single surface, applying a U value to every single surface, then finding historical weather data to get your design temperatures. No, it's very difficult. Solar thermal, a bit easier. So I believe, I haven't been on there because we use a different calculator that's our own, but I believe you can find an Excel sheet, and it is called, well, it'd be a solar thermal MCS calculator of some description. It used to be on the Microgeneration Certification Scheme website, or if you just search MCS on Google, it would be under tools for installers. Yeah, you might have trouble. At very worst, do search online. There's an Excel solar thermal calculator, and there is one. There are things around the collectors that you need to understand, some figures. That could be a struggle. Equally, fundamentally with solar thermal, it's quite easy though. It's the pitch and orientation of roof, the aperture area, how many panels, the size of the cylinder and occupancy. If, again, I don't know if, I'll give my email at the end and stuff, but if you drop me an email or even go on the website, greensquare.co.uk, let's not give out emails necessarily, there's an inquiry form on there. If you go on there and you really do want to do it yourself, no problem with that. It's probably easier if I just do it for you there and then. But if you did want to do it yourself, I'll email you the Excel calculator and you can do it yourself. So Lee, yeah, if you should find a solar thermal calculator online. If you don't, drop us an email and just say Richard said you'd email me this, and I'll email it straight out to you. As I say, on the website there is an RHI calculator if you go yourself. It's dumbed down. It is dumbed down, but it gives you a kind of indication. So, sorry, don't apologise, Esther. Could you explain how the combination of solar thermal with biomass air ground works with the two incentives again, as there was some breaking up? I heard it could result across the 1 or 2 cases. Yeah. So the way it works is we're using 2 different grants on 2 different technologies. So we're meeting all the rules. Because you can't, if you use Green Homes Grant, you've got to take it off the RHI. But I'm going to use the Green Homes Grant on your solar aspect, and the RHI is on your air source, ground source, biomass aspect. So we've definitely got 2 grants. Well, the first grant, Green Homes Grant, I'm going to use all of that £5,000. Why? Because the quote is going to be £7,500, roughly, give or take a few pound. That's what it is going to be. That isn't going to include the installation of all the solar thermal. I'm going to install a new domestic hot water cylinder and volumizer. So it's all will work with whatever system you've got, but it's heat pump ready. and I'm going to incorporate a lot of that heat pump cost in there. So that's going to cost you 7.5, 5,000 up front, that's £2,500 net. Now I'm going to do the air source, for example, a biomass boiler. Let's mix it up a bit. So we've got a biomass boiler now. Well, I've done all the cylinder cupboards ready for it. So actually my cost now is on a biomass boiler, a flue, a hearth, and 2 pipes to get from the biomass boiler to the cupboard. Everything else has been done and incorporated under solar thermal under this £2,500. So your biomass boiler, you're going to get £12,000 back. To install that biomass boiler is going to cost £9,000, roughly speaking, £10,000. So we paid 2.5 and we've got 7.5 worth. Now we're going to pay 10,000, but over 7 years we're going to get back 12,000. So I've just made £2,000 from that over 7 years, and I've just got, so actually under those circumstances, net cost after 7 years, this isn't capital outlay, this is just your net cost after 7 years after the RHI term on in that example would be £500. Air source heat pump slightly different, bit cheaper capital cost, but a bit less coming back from the RHI, but fundamentally the same thing. So probably cost around £11,000 if we've done all the cylinder cupboard under the Green Homes Grant solar thermal aspect. Cost £11,000, you're going to get about £11,000 back. Therefore, your net cost would have been there £2,500. So roughly 1 to 2, yeah, I'm not far off there. So about £1,000 to £2,000 net if you take the two together using both the Green Homes Grant and the RHI, but on different technologies, even though these technologies overlap when we get to the cylinder cupboard. Does that make, I hope that makes sense. You can see how we're working it. Rather than going, right, my air source heat pump is £15,000, you get 11 back, and the Green Homes and the solar is £4,000 because I've done all the cylinder, and you'll get arguably 2,670 back. Well, that's more expensive. What I'm kind of doing is putting some of the heat pump into the solar thermal to beef that up so you get the full Green Homes Grant. It's all within the rule. You're not doing anything wrong here, by the way. This is all totally legitimate and fair to do and right to do and transparent. We lodge everything, so there's no committing fraud or anything. This is all within the scheme rules. All we're doing is moving the cost of the cylinder, fundamentally, plant area, your airing cupboard, if you like. We're moving that cost into the solar thermal, removing it from the air source heat pump. This brings down the cost of the air source heat pump, puts up the cost of the solar. We don't mind that. Why? Because we've got this £5,000 Green Homes Grant. So I hope that kind of makes sense, how we use the two together for you there, Esther. So I'm looking to cover my air source heat pump with the RHI grant. Can I buy the new cylinder as a secondary? Yes. Carmen, good one. You could. I don't. Oh no. So on the secondary, it doesn't talk about cylinder. It talks about a cylinder jacket. So no, actually, Esther, with that, nice try, but no, you couldn't, because you would need a new cylinder for your solar thermal. I'm guessing pretty much, unless you've already got one, and you said, oh, I happen to have a solar cylinder, even though I've got no solar, which is really rare. Some people future-proof, but not many people. So no, that wouldn't work, actually. Kind of, I get it. If the cylinder was part of the secondary, you'd be right, but actually a cylinder isn't, only a cylinder jacket. Is it also a good idea to get solar PV done at the same time? It's hopefully cheaper to do at the same time, change radiators to electric. No. PV is a totally separate discipline. It's got nothing to do with what we're doing at all. The only saving might be is if we could put up solar thermal and we've got scaffolding up, you could use the scaffolding. That is the only thing. Why would you want to change your radiators to electric? They're the most expensive cost that you can possibly buy. So I'm going to say, if you're thinking of changing radiators to electric, definitely could you give me a call first, please? Because you definitely don't want to be doing that. There are much lower cost stuff to do. So no, don't. Again, people think, well, I'll get electric radiators and I'll get solar PV and I'm off grid. No, you're not, because your solar PV is in the winter when you need all that heat. It's going to be dark outside at 4 o'clock and there's nothing. You're going to be paying full whack on your electricity at 15 pence a kilowatt hour. Our customers enjoy around 3 pence a kilowatt hour. So I wouldn't advise doing that at all.
I think that's the end of the questions, actually, Richard. Unless anyone's got any more questions? I can't see any. Any more?
Yeah, I should have made a good point about the fuel savings. Yeah, I'm not really talked about fuel savings here, but the fuel savings, depending on what you're on at the moment, could be substantial. If you're on night storage heaters, again, you know, give us a call because we'll save you a lot of money. So I hope that's all. I hope I've answered your question. Thank you for thanks for the website. Go to the website, leave an inquiry, and just ask for Richard, or just say you saw Richard or something, and I'll be able to look after that.
Well, thank you very much, Richard. It's been really, really useful. I've learnt a huge amount, and I hope everyone else has too.